In 1945, the US dropped 2 nuclear bombs on Japan, which changed the course of the Second World War. 17 years later, another nuclear explosion changed the course of the Cold War. Except this explosion happened in space. The explosion of Starfish Prime was a pivotal moment in the space race that reshaped our perception of nuclear warfare. This story is crucial for understanding how we arrived at today's space policies, and why it's imperative no nation is allowed to place nuclear weapons in orbit. Join me today as we discuss what Starfish Prime was, the critical lessons it taught us, and why we don't send nukes into space anymore. In the early 1960s, the US launched a series of 5 nuclear tests in outer space, known as Operation Fishbowl. Their aim was both military and scientific. The military wanted to study the effectiveness of nukes as anti-ballistic missile measures, and how a space-based blast might interfere with electronics, communication, and military operations on the ground. Scientists wanted to know how a space explosion would impact the Earth's magnetosphere, and what kind of electromagnetic pulse it would generate. Starfish Prime was the first successful blast of the bunch. On July 9, 1962, almost 1,500 kilometers west-southwest of Hawaii, a Thor rocket carrying a 1.4 megaton thermonuclear warhead launched for the stars. That's 500 times more powerful than the one that destroyed Hiroshima. "27 smaller missiles loaded with scientific instruments were fired up alongside it to gather data on the blast and its subsequent effects. As the Thor rocket raced upwards, the nuke finally exploded at an altitude of 400 kilometers, about the height of the International Space Station today. What a sight it must have been. Ionized particles from the explosion collided with molecules in the Earth's atmosphere, creating widespread auroras visible across the Pacific, even as far away as New Zealand. Just below the explosion, the cloudy night sky of Honolulu was lit up for a full 6 minutes. It was as though another sun had emerged at 11 p.m. Radio stations wavered, a siren was set off, and streetlights across Hawaii were even knocked out. The historical context of Starfish Prime is important. The early 1960s marked one of the most tense periods of the Cold War, with the US and the Soviet Union locked in a fierce struggle for global dominance. Both superpowers sought to outdo each other in military strength, political influence, and technological prowess. The space race became a key battleground, and by 1961, the Soviets had the upper hand. They successfully sent the first rocket into space in 1957. And 4 years later, Yuri Gagarin became the first human in space. Pressure on the US intensified, as it began to fear the Soviets might develop space-based military power before them. With tensions escalating after incidents like the Berlin crisis, both nations saw the militarization of space as a way to gain a strategic advantage in the Cold War. This sparked a race to develop nuclear weapons, missile defense systems, and other technologies that could be deployed in space. Military planners were concerned about how these nuclear weapons could be used in space, and what effects the detonation of such weapons might have on global military strategy. More specifically, they were worried about the electromagnetic pulse, or EMP, that would follow such an explosion. An electromagnetic pulse is a burst of electromagnetic radiation produced by a nuclear explosion, especially high-altitude or space-based detonations. This pulse can generate powerful electric and magnetic fields capable of disabling electrical circuits, disrupting communications, and causing widespread damage to infrastructure like power grids, satellites, and radio systems. Back in the early 1960s, scientists knew that nuclear blasts produce EMPs, but the full scale and potential damage of such EMPs was not well understood. Operation Fishbowl was a chance to study these effects more closely. launched from Johnston Atoll. Operation Fishbowl was a series of 5 high-altitude tests conducted by the US in the early 1960s. 3 months after Starfish Prime, the US launched the remaining 4 tests in a span of just 2 weeks. The second test, eerily named Checkmate, launched on October 20th, 1962. The 20-kiloton bomb, similar in size to the one dropped on Hiroshima, detonated at an altitude of 147 kilometers. This was rapidly followed by Bluegill Triple Prime on the 26th of October, Kingfish on November 1st, and finally Tightrope on November 4th, 1962. Bluegill Triple Prime and Tightrope were both smaller explosions that detonated at 48 and 23-kilometer altitudes respectively. Bluegill Triple Prime was aimed at understanding lower atmospheric effects of such explosions in the mesosphere, while Tightrope was conducted as an anti-missile test in the stratosphere. NASA defines space as starting at an altitude of 80 kilometers, so I suppose these nuke tests weren't strictly carried out in space. Kingfish was. Its 0.41 megatons detonated 95 kilometers above sea level. But these paled in comparison to the explosion of Starfish Prime. The immediate impact of Starfish Prime struck awe into those who saw it. Auroras stretching thousands of miles. A fireball over Hawaii, all happening in total silence. If you enjoyed this video, leave a like, drop a comment, and share it with your friends. Subscribe and turn on the bell so you never miss our next cosmic adventure. Unlike explosions on the ground, when a nuclear detonation happens in space, you can't feel a shockwave or hear a sound. There is no mushroom cloud or double flash. There's just a bright ball of plasma, which changes colors like a lava lamp, as charged particles are pushed down into the atmosphere by Earth's magnetic field. These colorful auroras give high-altitude nuclear explosions the nickname rainbow bombs. But the lasting effects of such an explosion are far from sunshine and rainbows. Starfish Prime impacted the Earth in 2 big ways. In 1958, US Space Mission Explorer 1 discovered that the Earth is surrounded by 2 donut-shaped regions of intense radiation. Today, we call them Van Allen belts, after the scientist who discovered them. These belts are made up of charged particles, mainly protons and electrons, trapped by Earth's magnetic field. They act as a protective shield against harmful solar radiation and cosmic rays, capturing high-energy particles from the sun's solar wind. The Starfish Prime explosion released such a quantity of charged particles into Earth's magnetosphere that it altered the composition and intensity of the natural Van Allen belts, and even created artificial radiation belts that were stronger and longer than the originals. These persisted for up to a decade, shortened the lifespans of several satellite systems, and interfered with telecommunications. They also destroyed 2 early satellites, Ariel 1, Britain's first satellite, and the first TV broadcasting satellite, Telstar 1. But that's not all Starfish Prime did. Remember the electromagnetic pulses I told you about earlier? Scientists knew the blast would emit them, but no one could have guessed just how intense they would be. Nuclear detonations emit gamma rays in all directions, also known as a Compton current. When they interact with Earth's atmosphere, they ionize air molecules and liberate high-energy electrons. Since Starfish Prime detonated at an altitude of 400 kilometers, these gamma rays collided with atoms in the upper atmosphere, creating a cascade of free electrons. Accelerated by Earth's magnetic field, these electrons produced a rapid and intense oscillation of electromagnetic fields. At high altitudes where the atmosphere is thinner, this pulse is able to spread much further than it would in a lower altitude explosion. The EMP from Starfish Prime spanned thousands of kilometers, damaging electrical systems far from the detonation site. Almost 1,500 kilometers away in Hawaii, streetlights went out, telephone lines were disrupted, and radio communications were affected, showing how vulnerable civilian infrastructure is to such an event. Starfish Prime made the world realize just how destructive an EMP can be. It revealed how vulnerable electrical grids, communications, and satellites would be to a nuclear EMP attack. If added to the strategic arsenal, it would give any military the capacity to cripple enemy infrastructure without direct contact or bloodshed. Starfish Prime also released an isotope called cadmium-109 on explosion, which was used to track the fallout and measure resulting contamination. While ground tests normally leave behind a characteristic localized fallout pattern, the effects of space testing were global. New Zealand rainwater was found to be contaminated with cadmium-109, which a 1966 Nature article attributed to Starfish Prime. These kinds of reports raised significant environmental concerns about the long-term impact of space-based detonations on Earth's atmosphere and environment. And imagine, Starfish Prime wasn't even the biggest bomb the US had ever detonated in space. That prize goes to Teak, from Operation Hardtack in 1958. At 3.88 megatons, it was over twice as big as Starfish Prime, and detonated at an altitude of 76.8 kilometers. It turned night into day, and cut many trans-Pacific high-frequency communication circuits. According to the Defense Nuclear Agency report on Operation Hardtack, it destroyed the ability of the normally ionized layers of the upper atmosphere to bend radio waves back to the Earth. The Soviets were also busy testing high-altitude nuclear explosions, detonating 7 space bombs over Kazakhstan between 1961 to 62. Known as Project K, their aims and effects were much the same as the US tests. Detonated at altitudes ranging between 40 and 600 feet, 300 kilometers. None were quite as big as the American bombs. They ranged in size from 1.2 to 300 kilotons, about 5 times smaller than Starfish Prime. On October 22, 1962, a 300 kiloton missile warhead known as Test Number 184 detonated near Zhezkazgan at an altitude of 290 kilometers. The EMPs generated started a fire that burned down the Karaganda power plant and blew over 1,000 kilometers of shallow buried power cables between Tselinograd and Alma-Ata. These learnings had serious Cold War implications, highlighting the need for international agreements to prevent nuclear testing in space. The unforeseen consequences of Starfish Prime eventually led both superpowers to reconsider space-based nuclear strategies. Just 1 year later, in 1963, the United States, the United Kingdom, and the Soviet Union came together and signed the Limited Nuclear Test Ban Treaty. It was more than just ink on paper. It was a protective shield, halting deadly detonations in the sky, in the seas, and out among the stars. It was a promise to life, to clear skies, to oceans free from silent radioactive scars. Then came 1967, and with it, the Outer Space Treaty, a declaration that space, the realm of dreams and exploration, must never become a battlefield. No nuclear weapons, no tools of mass destruction would be allowed to drift among the stars or lie dormant on distant moons. Have you ever wondered, what if we hadn't acted back then? What would our skies look like today? If war had followed us beyond Earth, would there be any peace left for humankind? Today, our modern world pulses with space-based infrastructure. Silent satellites circling above are the lifelines of our civilization. They power GPS, enable communication, drive the internet, guide every signal and transmission that links one corner of Earth to another. From a single treaty, we saved the sky. nuclear explosion in space wouldn't just be distant light in the void. It would be catastrophe cascading down upon Earth. Global commerce would collapse in silence. Trade routes grinding to a halt, as if the world's arteries had clotted overnight. Our electronics and power grids, fried in an instant, leaving hospitals in the dark, cities without a heartbeat, and nations kneeling before the invisible storm. Life-saving machines would fall silent. Millions of tons of food would spoil as preservation systems fail. And financial markets, so delicately balanced, would crumble like sandcastles before a rising tide. The threat of a nuclear EMP is far more terrifying today than it was in the 1960s. Because today, humanity is wired into its machines, dependent on the unseen. We no longer just use technology. We live inside it. Sure, we have treaties in place, signatures on paper that promise peace in space. But ask yourself, could destruction still slip through the cracks? What if the enemy isn't war, but the sun itself? In 1859, long before satellites and smartphones, a solar tempest, the Carrington event, swept across our skies. It lit the heavens with auroras seen as far south as Cuba and Honolulu. So brilliant that people in the northern United States could read their morning newspapers by the light of dancing colors. Can you imagine what such a storm would do today? It wasn't just a light show in the sky. The Carrington event once sent sparks bursting from telegraph lines across the United States. Some so intense, they actually ignited fires. Now imagine, if a solar storm of that magnitude were to strike us today. The damage could rival a nuclear detonation in space. A modern-day Starfish Prime. Thankfully, such solar catastrophes are rare. But not all dangers come from the stars. Some are born right here, on Earth. Earlier this year, the world watched in alarm as Russia vetoed a United Nations resolution. A resolution meant to prevent the placement of nuclear weapons in space. Soon after, headlines spread like wildfire. Speculation followed. Some sources now suggest that Russia may be preparing to place a nuclear warhead into low Earth orbit. John Plum, U.S. Assistant Secretary of Defense for Space Policy, raised a chilling concern. He warned that Russia is developing a new type of anti-satellite weapon, a satellite carrying a nuclear device. Just one such device could threaten the entire web of satellites above us, disrupting communications, disabling weather tracking, halting agricultural coordination, derailing global commerce, even crippling national defense systems. And yet, this would directly violate the Outer Space Treaty of 1967, a treaty still technically in force today, but, tragically, one without any real power to prevent what might come next. Could this be the beginning of a new arms race? One not fought on the ground, but in the sky above us? These international agreements were not created in silence. They were forged to prevent the stars above from becoming a stage for our darkest weapons. They must be honored, because within them lies the promise of our safety, our shared future. As space becomes ever more vital to modern life, the warnings of history grow louder. Starfish Prime wasn't just a test. It was a reckoning. That explosion in space unleashed electromagnetic waves that shattered infrastructure. Radiation spilled into the upper atmosphere, lingered for years. Satellites were disabled. The very edge of our world became tainted. It was a turning point, a moment that revealed a hard truth. Space, if weaponized, could bring devastation not to one nation, but to all of humanity. That's why today, international treaties stand as shields between peace and annihilation. They are not just signatures on paper. They are sacred promises to the future, that space will remain a realm of wonder and peace, not war and ruin. And that is why responsible, peaceful space exploration matters so deeply. so that we may continue reaching beyond, unraveling the mysteries of the universe, making discoveries that unite us, inspire us, without the shadow of extinction darkening the light of our greatest achievements. Thanks for watching, all the way to the end. If you enjoyed this video, you'll probably love our other stories about space history, like the time Zambia entered the space race and dreamed of reaching Mars. Click here to watch it next. A huge thanks to all our amazing patrons and members. Your consistent support is what allows us to plan ahead and create thoughtful content like this. If you'd like to see your name in the credits of every video, or submit questions directly to our team, check the links below to join. All the best, and I'll see you in the next one. If you enjoyed this video, leave a like, drop a comment, and share it with your friends. Subscribe and turn on the bell so you never miss our next cosmic adventure.